as you might already know, this is part of our efforts to give opportunity for our young people to interact with leaders from the industry to help them to be aware of what is happening in the world of work and thus prepare for our transition from campus life to corporate life. So that's what our objective, and I think the topic and the speaker for today is really exciting and very relevant to the times that we are living in. So, my own first introduction to the world of artificial intelligence was back in the early 2000s when I was doing my mechanical engineering, and at that time one of our professors was doing some his research, his PhD, and his research topic was in evolutionary algorithms and genetic algorithms, and also some about neural networks. So that it was back then when I got a little bit of introduction to it, when I got to work with him as part of his project. So at that time we were trying to implement some of these algorithms from scratch in C and all that. But after that, I need to admit that I didn't get any opportunity to work in that segment. So now that things are going the way they are, maybe it is time for me also to catch up. As you all know, this artificial intelligence is really taking the world by storm. The kind of advances which are happening. Almost every day. The number of new papers and new AI models which are getting released is mind-boggling, and the kind of capabilities these algorithms are having is also very interesting, and we are all watching how this is evolving. So thus mentioning as a context to what we are going to discuss today, I am very happy to welcome Mr. Rajiv MA from Tata Consultancy Services. He's an enterprise architect at TCS, where he helps develop large-scale enterprise systems for the multinational clients of TCS, and he is also heading the artificial intelligence lab at TCS Kochi. So, the very right person to talk to us. He has had an illustrious career, helping large multinational clients with their enterprise systems. So, really the right person for us to listen to. And what makes Rajiv all the more interesting is also how he has been in touch with both the startup ecosystem through the Kerala Startup Mission, where he helps mentor startups, and also through his various interactions with the academic world also. So he is part of some research projects at the National Institute of Fashion Technology. He is part of the internal quality assurance cell at QSAT, and has also been associated with board of studies of various Kerala colleges. So somebody who has straddled both the industrial and academic world. So really excited to listen from you, Rajiv. So without much further ado, let me hand over to you. Welcome to everyone. Just one more comment. Probably, let us keep this session interactive. I would like all our friends who are joining to use this as an opportunity to interact with the speaker, and if you have doubts, you can ask. Be prepared with some questions that would also benefit all the others who are participating by making the program more interactive and fun. So, with that, let me welcome Rajiv to speak to us.
Yeah, thank you, Anand. Let me share my screen and let me know once you're able to see it. Please let me know if you are able to see my screen. Are you able to see my screen?
Yes, sir.
Okay, thank you. Yeah. So as Anand said, I did ask about who are the audience for this type of sessions, and I was told that majority of them are students or people who are relatively new to that. So that is the reason why I chose a topic like why everyone should embrace the future of technology, because especially a field like AI, I've been in this field for quite some time, and the amount of progress I see on a day-to-day basis is tremendous from what was possible a decade ago. So anything should start with business. See, when does something grow? When you have a business opportunity, and this is a market share that you can look at from the software perspective of that. It is continuously growing, and it is growing at a tremendous pace. When the economies are growing at 4%, 5%, I feel like AI is growing at 20, 25, close to 20% or 25% overall. This is just the software growth, and in terms of revenues, you can see this is closely touching $300 billion by 2027 in terms of just software. And typically, if you look at that, it's basically a combination of software, hardware plus services that forms that, and with a CAGR of 36%, we are billions of dollars here that is there. So where do India fit into this overall spectrum? Obviously, we have been strong in the services side of it. Obviously, that's where we are going to use GenAI a lot. Are we strong in hardware side? No. Currently, the answer is no. Actually, we are probably 2 to 3 decades away from some countries like Taiwan and all. So we are far away from that. But obviously, software and software services, we are still strong. And utilizing that as part of our growth is very much required. That. Let me give you an example with a company. You might have all heard of NVIDIA, who makes chips actually. So if you look at the last 5 years of their growth, that clearly tells you where the field is heading. Because if you really see, they are a very niche company, predominantly making graphics card, and some related software around it. And if you look at their growth, if you have invested ₹1 in 5 years back in this company, today it is 25 times. And that tells you what is the importance of the field and what is really happening. Nowhere you will see a growth of this high amount. 5 years, 25 times is not normally what you see. Even if you put a fixed deposit, it will not even double in 5 years, leave alone 25 times. So that clearly tells you the amount of push that's happening in the world with respect to the field of AI. But then there are a lot of hypes also around that. People tend to compare it with, human capability and all. I don't want to get into that. It's nowhere close to human capability, that is for sure. But there are certain things it can do what humans can't do actually. So there is a strength that it has over there. So the necessity for AI is well established. It is just a matter of time whether we accept that, and what do we do for that actually. So why is a lot of people pitching for AI? To understand that there are a lot of problems today that it cannot be solved using the traditional methods. One is the classic case of drug discovery. Drug discovery is a very complex process. If you really look at a drug manufacturing, it takes around 10 years, all the way from identifying the compounds, narrowing down to certain candidates, then building the tablets, putting clinical trial on that, seeing how it's behaving on the person, and if there are adverse reactions, make changes to that. And so typically a drug, overall a drug life cycle, if you see, all the way from inception to basically getting into the market and doing it in a large scale, it is a 5 to 10 year cycle. So feel like AI can actually shorten this time to 1 or 2 years. A classic example is like during COVID. If you see, all the COVID vaccines were made in less than 2 years, or actually some of them were made in hardly like 6 to 9 months time, because that was a very much necessity at that time. But did we have sufficient time to test the drug on all the humans to understand the adverse action? No, we did not have that. Sometimes drug testing takes its own time per se, but basic idea is very simple. AI can shorten such times, and added to that, it allows you to identify compounds much more uh, you know easily compared to what we have been doing. And today we are already talking about what is called personalized medicine. Personalized medicine means today, if somebody has a cancer, everybody is treated the same way actually. But going forward, it will not be the same case. If there are 5 people who have cancers, all the 5 will be given different dosages of the drug or different variations of the drug, and that is only possible if you customize the drug to an individual person. And very important, where AI can add a lot of value in these type of things. Another example is material design. So material design forms core of a lot of things what we do. So today we talk about lithium ion batteries. What is the problem with the lithium ion batteries? Obviously the problem is heat generation, or explosion that can happen because of the high energy density. So that's where we come up with lithium iron phosphate. Instead of pure lithium ion, we have lithium iron phosphate type of things, which are used in cars and stuffs, which have a lower energy density but have a higher safety record. So material design is one area where a lot of progress can be made with the use of AI and stuff. So I'm giving you some examples just to think through the possibilities, because a lot of times we hear areas like banking software, retail software and stuff, but there are a lot of research areas which traditional software cannot really solve these problems, but whereas AI can accelerate some of these cases. Another case is basically the energy efficiency. See, today AI consumes a lot of power. If you understand, the data center power usage has increased when AI has gone up. So obviously there is a necessity to reduce the power, and there are a lot of things that are happening in terms of cooling technologies, in terms of newer chips which consume less power. One classic case is photonic chips. Instead of electrons, we are slowly getting into photonic chips, which basically consumes far less power compared to an electronic chips. But it will take 1 to 2 decades for photonics to manufacture. Photonics was always used in the industry, but it was predominantly for transmission of data across continents. So you might have heard of undersea cables. So you transmit large amounts of data through the photonic thing. But photonics being used for computation itself is a big field by then. So, but basic idea is that, how do we reduce the power consumption in the data centers and make them more energy efficient? And energy efficiency applies to many areas. It applies to wherever you are using for heating of the homes, electric cars, all basically it's about, or appliances, use of appliance, you want to do that. So it's one area where again AI can give a lot of benefit in terms of that. Another area is the smart grid balancing. Classic case is that today we are generating solar power at each individual house. So what is the problem with that? The problem with that is that you do not have a way to predict how much energy will be pumped in by consumers into the network. So that's why today we call it as prosumers, consumer plus a producer. You are not only a consumer of energy, you are producing the energy from your house itself actually. The problem with that is that, especially like a country like India, where we have a centralized grid, when large amounts of energy comes quickly, that causes instability to the grid, so grid balancing by itself is a very very complex problem, uh, uh, per se. Some countries, they have decentralized grid. In a decentralized grid, even though a small grid goes down, uh, you might not have a major problem. But in India, if the southern grid goes down, it affects 3-4 states per se. So again, a very very complex problem which traditional softwares cannot solve. You need optimizations, you need mechanisms to predict the energy demand as well as the energy production also, because sunlight varies on a day-to-day basis. So today you might be generating X amount, tomorrow you might be just generating X by 2 because of the cloudiness and stuff. So the variations in energy generations are very high. So I have given you 4 examples. These are not the overall examples. Why I took something different than what you traditionally hear with AI, was to ensure that there are very very complex problems which traditional softwares cannot solve, and use of AI really helps here actually. Now moving on, what type of roles, job roles is the first thing that you might ask. What is the role that I can play? See, there are so many different types of roles when it comes to AI. You could be simply a salesperson who needs a basic knowledge of AI to sell your product, which probably is using the AI. So in which case your skill sets are very different, as opposed to somebody who is creating training materials for AI, or a robotics engineer who is basically embedding the knowledge onto the systems, which could be detached itself, something like an autonomous car. An autonomous car, when not connected to a network, also should run, and it does run also. So it has its own intelligence locally available, even though it loses connectivity to the cloud. It still can work independently even if you lose connection to that. So there is an intelligence to that. Data engineers, business intelligence, chip designers, even designing low powered chips with high performance. It's a very specialized field which requires a lot of knowledge in certain thing. Machine learning engineers, which are the most common type of roles that people will be looking at. Data analysts, systems engineers. So there are different types of roles which requires different skill sets actually. Uh, in some of the things, like if you're becoming a machine learning engineer or if you're becoming a research scientist, you need to go deeper into the field. Where things like statistics, linear algebra and others starts coming into picture, where that. Whereas if you are doing a sales role, that might not be of a major concern to you. So there is no single skill set for all these things. It varies extremely, and it depends on the type of role you want to play. But there are so many roles. This is not the full list. I just listed some of them which are here actually. So that leads to, what type of things are we seeing? Obviously, we talk about terminologies. At times, people tend to get confused because we tend to call everything as under the artificial intelligence, even though it's a very larger branch. Most of the people, when they call AI today, they're talking about a field called machine learning actually. And there are some subfields within that called deep learning and generative AI. Especially, like you might have heard the term generative AI and all after basically OpenAI came up with the chatbots and stuff which you can use. So basically understand the field that behind the scene of all this lot of things, optimization is what you are optimizing for something actually. You are building an algorithm which is optimized for some purpose, and that involves a lot of math. So if you are really who's going into the crux of the problem, You cannot survive without math, stats, probability, and linear algebra. It is fundamental to the type of work you do actually. But if you are a salesperson, you don't have to get into such so much details, except that you need to understand at the higher level. So if you really look at what accelerated this entire AI in the last decade, assuming 2014 cutoff, if you work to that, a huge acceleration has happened from 2014 to 2024, 10 years, currently 24 we are in. Obviously, access to data, and that too, data, what is called unstructured data. See, machine learning has been applied to structured data for quite some time, 3 to 4 decades, I think. So that's not a new field. But machine learning has been applied to unstructured data, images, videos, voice, and text in the last 10 years more, because obviously infrastructure matters a lot. Your computation capacity matters a lot, and that's where the graphics processing units gave a big boost actually. So GPUs gave a big boost to the entire field. But there are so many different infrastructure capabilities that has even the CPUs have gone a lot. Today you can do a lot of inference on the CPUs itself. You don't need an accelerator like that. If you want very low latency, you can go through an FPGA type of thing. So 3 things that really changed our data infrastructure and algorithms that led to the basically the acceleration of the field. Today, it is very easy to identify patterns with images and stuff, or the videos. So you might have seen all the Gen AI. Today, people can just type the text and generate images on the fly. If I were to say I need an image where elephant sitting on top of a cycle, you get an image which is generated by the Gen AI type of things actually. So have we mastered all these fields in the pattern identification? Answer is no. We are very early stages, but we can still do amazing stuff with the capability that we have today. Even voice generation, text generation. What does ChatGPT do actually? You ask a question, it basically answers the question, in a textual form actually. And we are getting into what is called multimodality also. So you can accept one input, you can give a different output. So when I say I need an image of an elephant sitting on top of a bicycle, I'm giving my input in the text form, but my output is coming in the image form, Or I can give an image and ask a question about that image, What do you see in the image? It gives you a textual explanation of that image. Or I give a text and say that I need a video of an elephant playing football for a duration of 3 minutes, And today there are capabilities which it can develop that. And when it comes to algorithms, again, in the structured data, we were basically using shallow learning algorithms. From 2000 onwards, we have been going more into a field called deep learning actually, which is basically modeled after the brain, which is called neural networks actually. So there is a lot of family of networks in this. There are hundreds and hundreds of algorithms per se. Again, coming to the ecosystem per se, from a programming language and frameworks perspective, what you should learn, Obviously, the most commonly used programming language is Python, but a lot of underlying code for performance code is written in C, C++, and Python is only a wrapper to that. And some of the frameworks that you will have to learn if you want to go on a coding path, is basically frameworks like NumPy, Pandas, SciPy, Scikit-learn, Matlib. And there are other programming languages also like R, Java, and Julia, which supports. There are many more actually. But if you're talking about performance code, you want high speed and stuff, still a lot of stuff is written in C, C++. And Python is only a wrapper onto that actually. And then coming to DL frameworks, obviously today, you have PyTorch, TensorFlow, and there are some older ones like Cafe, MXNet, Apache, Spark. So I would say the most used framework today probably are PyTorch and TensorFlow when it comes to the DL frameworks per se actually. And from a cloud capability perspective, you have a lot of services, AI services today available as part of the cloud actually, So let us say you have a scanned PDF document or scanned document. You want to extract text out of it. See, you don't have to develop a solution today. You can just make a call to any of the cloud provider services for OCR, optical character recognition. It can take an image, a scanned image, and give you the text output of it, very easily actually. So there is a lot of capability today available as part of the cloud per se. But if you are a core developer who wants to build your own model for doing something, you still can do that actually. As I said, the roles varies and what you want to do, and traditionally there are three overarching field when it comes to machine learning. One is called supervised learning, one is called unsupervised, and one is called reinforcement learning. I'm not going to go into deep of it. In the supervised learning, you train a system by giving annotated data, so you show 1,000 images of cats and 1,000 images of dogs. The system automatically learns the pattern to say that next time you show a cat or a dog, I can identify a cat or a dog. So what you did label the 1,000 dogs and 1,000 cats to say that these images are dogs, these images are cats. I know that. So that system used that pattern to do that supervised learning. Unsupervised learning is basically you do not have tagged data, but you still want to learn patterns, which you can do that. And then reinforcement learning is basically a different paradigm which is used in robotics and other fields, basically where to reward an algorithm based on the performance it has, with respect to that actually. So I'm not going to go deeper into that, but basically a lot of things revolves around these three fields. There are a lot of variations and stuff to each of these, but those are all questionable, and here is a list of algorithms. There are thousands and thousands. Only hardly 100 are listed here. But what is more interesting is that they are categorized into some categories, So they are categorized into, first category is machine learning algorithm, which is basically the statistical machine learning part of it actually. And the last, if you see in the top row, the last one is called the deep learning algorithms, which are modeled around the brain actually, which is the neural network aspect of it. Then you have applications of this. These algorithms can be applied to natural language, either for natural language generation or understanding, or it could be any different purpose. So let us say when you interact today, you do speech to text. So you take your mobile, you record a voice, but theoretically, as of now, the voice clip is stored just like that. But you can easily, if WhatsApp wants to convert that into voice to text, they can basically convert your voice into text, and instead of the voice, they can just put the text out there, so type of thing, natural language type of a field, computer vision as a field, obviously detecting objects of interest, how far are they away from you, something like autonomous cars use a lot of them actually. Then reinforcement learning algorithms, as I said, used in certain fields like Q learning, deep Q networks and stuff there. And then optimization. Behind the scene, everything is optimization actually. The technique you use differs. I think Anand was talking about neural networks and other things which he learned. So obviously there are different algorithms, gradient descent being one of the most commonly used actually, but you could use genetic algorithm based optimizations and things like that actually. And then, how do you ensemble algorithms per se? At times, you mix and match different algorithms to come up with the strategy. Recommender systems, today, how do you recommend books of interest or videos of interest or voice? See, when you watch YouTube, you should watch that they start recommending certain things to you based on the pattern of your watching, classic case is you start watching something like a Ukraine Russia war for a couple of days, you start getting more videos of that thing because they understand that that is something of interest to you, and then do that. Recommendation is a big field by itself, then areas like anomaly detection, graph algorithms, to identify fraudulent patterns and stuff per se. So categories are more important. The number of algorithms are I would say probably more than 50,000 or probably a 0.1 million plus, algorithms are today exist actually. So we can't master all of them, but if you can master one or two in each of this category, you are still good enough, per se. And that takes me to the stack per se. If you were to go assuming I have kept all the roles different and just assuming you are going into the programming to develop your own models or infer your own models developed, what type of a skill set you need. So obviously the top is you are trying to build a business solution. So every see, technology is only a means to enable a business. So ultimately what you want to do in your business is what really drives the use of technology. Otherwise technology by itself has no value. It is to build a business solution that it has value. So obviously developers need certain type of tools. That's where you have integrated development environments, then you have annotation tools, then you have profiling tools in the developer's kitty, then you use a certain algorithm or neural network topology to solve the problem. In order to basically implement that, you could either implement it yourself or you could use a framework which has already implemented some of these algorithms to solve the problem, in which case you use that deployment. So there are quite a few different layers that you do that. Typically an application programmer works from the deployment orchestration upwards. A systems programmer typically works the downwards. So if you are a systems engineer focusing on AI ML, the stack that you work will be lower level. For a salesperson, he needs to higher level understand that he needs to understand the business solution and how the business solution is being solved. Probably he doesn't need any of the bottom level things here. Only probably the first layer is of interest to him. Type of a thing. I don't want to go into deeper into that, but if you are a programmer who wants to go deeper into the solution building of it, you will be focusing from here upwards. If you are a systems engineer who wants to build lower level libraries and stuff for the AI ML, you will be or coming up with a new neural network architecture itself, you will be doing at the lower level of it actually. And this takes us to the man machine continuum, because you need to understand that always in a man machine continuum, certain times, earlier machines had zero capabilities, man had all the capabilities. Then over a period of time, the capabilities, certain capabilities that man had started moving into machines. uh, and the quantity of that interaction is slowly changing, where we have used small repetitive task automation first, then assisted intelligence, then augmented intelligence, and towards we are getting into autonomous intelligence. So when you say an autonomous car in the category 5, it basically doesn't need any human input actually per se. But there is no car today which is in the autonomous level 5. Most of the cars are in the level 3, where most of the time it doesn't need a human, but at times it needs a human when it is in trouble. So we are at level 3. We have not reached level 5 per se, but ultimate aim is going towards a stage of autonomous intelligence by itself, per se. There is other classifications also. Some people call it as narrow intelligence, general intelligence and super intelligence, ANI, AGI, and ASI actually, per se. But obviously what you need to understand is that man-machine continuum that's happening, where more and more human tasks are getting automated, that obviously raises the question of does that mean job loss or things like that? I don't want to get into specifically. I don't see it as job loss. I always see things as job shift. The people who get into trouble are the ones who do not change. The people who change do not get into trouble that easily, and this is where a lot of people whom I have seen get stuck. They don't move on when everything else around them moves on, uh, uh, and it's very important to understand this aspect of it, and that comes to the closing thoughts per se. What does the future of work look like? Obviously, continuous learning is becoming a the knowledge around us is changing so fast. So that leads us to continuous learning, which involves upskilling, reskilling, and unlearning also. Because sometimes it's very important. A lot of people ask the question, why is it take 2 hours for a youngster to learn something, whereas it takes 3 hours for a experienced person to learn? Actually, the reason is that for a new person, there is no unlearning required, whereas a person who has worked on so much has to do an unlearning also. So the continuous learning involves not only adding knowledge, sometimes it is eliminating certain knowledge you don't require also, or it is not, that knowledge is wrong, or basically is no more valid per se actually. Then, you know able to solve problems which involves, you know advanced problems, things like healthcare. Can we use AI to solve healthcare problems, which today, see, one of the problem today in healthcare is the cost. The healthcare cost is constantly increasing, whether it's a medicinal cost or if it's a cost involved in a thing. What is the reason? Obviously medicine cost, it is basically the medicine by itself is very cheap. Most of the medicine are manufactured very cheaply because they comes from generic drugs and stuff like that. But in spite of which you spend, like, let us say 30 or 40 rupees per a tablet. The tablet is just, it is the manufacturing cost will be like 30 paise or something. But why am I paying 100 times that? It is actually the research cost. The research cost of identifying the drug, doing all clinical trials, all those things basically is the cost. So obviously, any advancements in healthcare really can bring down some of this cost per se. Other area that we discussed is, does the impact of AI leads to job shift or job loss? As I said, I always see it as job shift, even though some people see it as job loss. Because I always see, when computers came, a lot of people said that amount of people in bank, the number of people required in bank will come down. If you ever understand, like 20 years, 25 years back, I am talking. But actually not. The amount of banking has only increased, and today every people have access to the banking per se. So obviously, what has really happened is job shift, not the job loss. People who were entering on the ledger were no more required, whereas you wanted people who could enter onto the system and basically tally at the end of the day, as opposed to enter onto a ledger and then tally at the end of the day. It's not a job loss per se. They did not adapt, and hence they saw it as a job loss, whereas people who adapted basically saw it as a job shift per se. And then areas where AI can be applied is the environmental sustainability aspect of it. We are already seeing climate and other issues per se. So where AI can add value to it. Then areas of scientific research and discovery, as I said, material design. There are many areas like that where AI can be applied, not extremely applied today, but it will get applied over. Then economic growth. How do we take technology penetrating into even people who do not have access to that? See, in India, if you ever see, we have, if you see, the cost of data has come down. Earlier days, for 100 200 rupees, you only used to get 1 GB of data. Today, with 350 rupees plan itself, you have unlimited data actually. Even though the speed might be less, but still you have unlimited data per se. So obviously, when technology penetrates, it values comes on, and basically the economic growth automatically happens. Access to information. See, today everybody has access to information. That was not the case 20 or 30 years back. People who went to college had only the access to information what was taught in the college. But today, I don't have to go to a college to understand what Stanford is teaching or what MIT is teaching in computer science. I can sit at my desk and still know that actually. And then increased productivity. See, obviously, technology penetration will increase productivity. And what we tend to think is, when the increase in productivity happens, job loss happens. That's how we normally correlate. No, that doesn't happen like that. Even though the productivity increase and number of people required comes less, new opportunities come in. See, that we don't take in that into picture, and that is why, even though number of people required was less, actually the number of jobs gets increased. So that's where job shift phases, job loss comes into picture. Yeah, with this closing thought, I want to stop so that I give you sufficient time for question and answers, because I did not know the crowd much actually. But if you want to go deeper into technology, I'm absolutely fine with that. Yeah, over to you.
Thank you. So, friends, now it is your turn. You can ask your questions. You can either put it in the chat box, or if you want, you can also unmute yourself and ask. While we wait, for the questions, I have one question.
Sure, sure.
If I am let's say, an accountant or a marketing kind of person, I am not planning to, get into training in neural network algorithms or anything like that. But I know that AI is going to impact the work I am currently doing. So how should I approach it? How should I, what should I learn? What do I do? How could we approach it?
Yeah. So different people have different. So when you say typically marketing or sales, so let us say I'm selling a product today. As a salesperson, it is your duty to highlight what are the capabilities that basically brings a differentiation to your product. And many salespeople are trained for that, to show that type of a difference in their product. Similarly, in the marketing field, so when you market product, basically what is the problem today? Let us say if I am into some field like I am doing a campaign. The question comes is my campaign very focused onto the people who are going to add value? I'll give you an example with respect to what Harley Davidson did. So Harley Davidson used to get so many inquiries, but out of which only a few percentage really gets converted into a business actually. So it's more like you get 200 inquiries, out of which only 20 really converts. So that means it is a 10 percentage. So 200, 20. So out of the overall, only 10 percentage gets converted. But they were sending this campaign to so many millions of people. They were not able to do that. So what they did is they basically used certain AI algorithm to start targeting to a much smaller crowd. And what they ended up with was amazing, that they were only sending to 50 people, out of which 20 basically turned into customers. So that is a huge hit actually, because if you see 20 or 50, that's a huge percentage per se. It's 40 percentage. So those type of things are today being used, and there are a lot of tools that can help you with respect to such activity, whether it is campaign management or areas like that. I think that is where you should be focusing, not from a see. That's where something called no code platforms comes into picture. See, because people like me are mostly working on a high code platforms. We build solutions with coding per se, but in your case, whether it's marketing or sales, you are using tools which helps you to do these type of things without writing any code per se, and there are so many such tools. I would say that should be your focus.
Thank you.
Rajiv, Ashita here. Thank you so much for that wonderful overview that you have given. I was really enjoying the session. So, just for the benefit of students, with this increasing demand for AI professionals, it's very important that they have the right skills and knowledge so that they'll find a job in this industry. How can students make a particular decision on a particular course?
Yeah. So from a, see, as I said, the type of role you play matters a lot actually, and the education that you require for that specific role. Because somebody has asked a question here with respect to AI used in business intelligence. See, today AI is a lot used in business intelligence, and today it's becoming conversational in nature also. Earlier, when you get a data, you had to analyze the data actually, but today with natural language interaction itself, you are able to. So if you use things like Power BI, Power BI from Microsoft, if you have a data, you can actually naturally interact with the data to gain insights of that. So simple thing is, you could ask, if the cost is increasing, which variable is also increasing along with it. And basically that can easily tell you that type of a thing. So it depends on what you are doing. But looking at the course per se, if you see, there are different paths people tend to use. Either they learn generic courses and then they specialized. So one pattern that I have seen is people take a BTech in computer science, then do a master's in AI. Or today we have some people who prefer to start with specialization itself. So they do a BTech in AI and a master's in AI actually, so which is much more specialized, and they have much more knowledge. So I can't say one is superior over another. Both has its own pros and cons, because in one case you get more specific into the field of AI. In the other case, you still get a overall generic per se. Uh, 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 is that what, Ashita, you are looking for?
Yeah, I just want to call out it here because a major of the audience was from student background itself, so thought it would help them in some or the other way. Thanks, Rajiv. Yes.
Yeah, absolutely, absolutely. Yeah, someone has posted that business intelligence. There are quite a few tools actually. As I said, Power BI is one of them actually. You could, if you are doing Google Analytics, there are tools for purpose. Because whenever you are in business intelligence, visualization becomes a very powerful. So if you ask me, there are two different types of people typically, who are left brained and who are right brained. People like me typically are more logic oriented and stuff. Then there are very creative people with right brains. Actually, business intelligence requires a combination of both actually. Predominantly, that visualization aspect comes from that, from the perspective of that creativity and stuff actually. So yeah, there are quite a few opportunities there. I've seen some very specialized business intelligence people who can come up with some amazing visualization aspect of charts, and because some people come up with their own way of presenting it, and it's very very important to get to that type of a skill. Because one problem I've seen myself personally with this field is that some people tend to think machine learning is easy, come to the field, and then later on they realize it involves a lot of math at the lower coding levels and stuff, if you're especially getting in, and then they get distracted actually. So for each role that I showed you, it requires different skill sets. So understand where your strength lies, and then basically choose that field. Don't jump into machine learning engineer just because you think that has opportunity, because more or less you will clearly understand over a period of time that ML engineer role is not for everybody, I think somebody has raised a hand. Please go ahead, if you have any questions,
Sir, Raju sir, one doubt, sir.
Yeah.
Sir, what about the impact of AI in, especially in mechanical department or in future?
See, impact will be see, today if you really look at when you say mechanical, see, let me take a case of additive manufacturing. Additive manufacturing, if you see 3D printing and other technologies which comes along with that, AI plays a huge role actually, per se. If you ever watch, I'm very interested in this Ukraine-Russia war. If you see, Ukraine is a very small country compared to Russia. It is almost in every factor it is 1/10 or lesser than that of Russia. But if you see, for past 2 years, Russia has not been able to make major progress. Having an army 10 times, but still, what is that makes different? If you really see, they use drone warfare, and they manufacture all the drones locally, and they use very sophisticated intelligence in the per se. So from a manufacturing perspective and even from the usage of the tools perspective, lot of intelligence is involved there. It is very precise intelligence that they use to basically destroy. Think about a case where a $200 drone is able to destroy a $200 million S-400 launcher, and today that's happening actually. That is a way of winning the war per se. I just gave you an example from the military perspective, but there are many areas where AI is used today in mechanical engineering for the perspective of either the manufacturing aspect of it or even the optimization, basically the lesser utilization of ingredients, CNC lathe for like areas like in the CNC lathe. So many areas it is being used actually. Even coming up with prototypes. I want to build a machine. What are the 5 or 10 prototypes I build, and what are its pros and cons to that? So impact is very high actually. People should be trained on this field. I'm sure that you are training them on CAD areas like CAD and other things, tools. So they are becoming very sophisticated and advanced with intelligence embedded onto them. Areas like finite element methods.
Yes, sir. Yes, sir.
See, there is no field AI has not touched. That is a misnomer. If somebody thinks there are some fields which AI has not touched, actually that's not correct. It has touched every field, including the style of teaching itself. Today, see, earlier days when we studied biology and all, they had small models. Today you can visually see a human being opened up, and each and every part you can visually see through augmented reality and stuff. Very advanced, where you will visual learning. Most of the people are visual learners actually. And once they visually see something, they don't normally forget that fast actually. So today a lot of things are possible, so including teaching. We have huge impact in teaching, because when you ask the mechanical, I'll give you another example. I went to a power plant some probably like 6 years back. They have some machines which were developed like which were installed like turbines which were installed like 30 to 40 years back. So what they were doing is all these machines had only engineering drawing. So they started building the AR VR model of this because these machines were repaired by people who have already retired. So nobody knows even how to remove the parts. So they built an AR VR model by which they could train a new engineer who is coming in to say that these are the 2000 steps you need to follow in this machine, all the way from removing this bolt to removing so and so that you can disassemble this entire large turbine, and then assemble it back. So there are so many places where it's being used actually. Yeah, there's no field that I have seen that AI is not touched. Even the creative fields are also being touched. Areas like movie making. So today I don't have to go anywhere out to build to make a half an hour movie, including the sound, everything I can do it at home actually if I need. And the shooting can be, even though the shooting do not happen in New York, I could take a video from New York, basically embed the my own characters onto that and still make a video out of it where I have not even gone into New York or something. Yeah, it's possible actually. Today a lot of things are possible like that. While sitting at your home you can do some of these things.
Thank you, sir. Thank you.
Yeah, I'm assuming there are no more questions. If you have anything also, just connect in LinkedIn or things like that. If I can be of any help, I will try to help you out. But there is no one path here actually. And don't think that these fields are very easy also. Some of the, especially if you are getting into programming, there is a lot to learn actually in this field. But if you are using a software by itself, probably not that much. But if you are developing your own code and coming to top of it involves actually. Yeah, over to you, Anand and Purnima.
Just one more little thing.
Sure.
Since we are an employability platform and we hire for many companies.
Mhm.
So what I am seeing is a lot of people who want to get into the field of AI. So they roughly know that Python is what is used there.
Uh-huh.
Okay, I want to get into AI. So Python is used. So they learn Python and come.
Mhm.
People need to understand that from there to getting to AI is much further away. Maybe a word of caution for people like that. I think would be good if something you could add to that.
Yeah. See, Python is only a programming language. Knowing Python do not give you any special capability in AI per se. See, what is more important is use of certain type of libraries which Python has created. So as I showed you, if you are dealing with data, so you need to like structured data, you need to deal with NumPy, pandas type of thing because you need to load the data. Then you need matplotlib type of libraries for visualization and stuff. So there is a huge ecosystem around Python which has been developed actually, and you need to master that ecosystem. That is more important actually. Like as I said about deep learning framework, it is about understanding PyTorch or TensorFlow and modeling your problem in these frameworks. That is what is more important. So Python by itself do not give you any capability per se. Uh, if you are dealing with structured data, you deal with frameworks like NumPy, Pandas, SciPy, scikit-learn, Matplotlib type of things. If you are dealing with unstructured and more complex data for pattern identification, you deal with deep learning frameworks like PyTorch, TensorFlow, MXNet, Apache, Spark type of thing. So I would say just because you know Python, how much do you know in AI? I would say it's almost zero, in AI. It is the ecosystem that's very important. And as I said, AI is a very vast field. you will not be even able to master 0.001% of this field, even if you spend like 20 years. It is that vast actually. So put a realistic expectation and then come and learn. But there are people who have learned a lot, but nevertheless the field is so fast changing and so vast that it is very difficult to master the entire field actually. So that would be my caution to that a lot of people, because it is all about expectation. If you set your right expectations, there are some very brilliant kids I have seen who have done excellent work in 3 to 4 years in this field. Yeah, Anand, that would be my suggestion. Try to have a mentor, because sometimes mentors can help a lot. Because at times one of the problem with learning that I've seen is you have 20 options in front of you. You can't take all the 20 options and learn. So what should be the one or two things should I learn for the given condition, that typically a mentor will be able to tell you very fast. That way you will not wander around with these 20 things. You will rather focus to specifically go where you want to go. So I would say having a good mentor in your journey will always help in this field. Otherwise you will wander, because this is such a large field.
Thank you. I think we should have send that word of caution also, because students should get the right kind of in getting into this field. So thank you for that. And I think I don't think there are any more questions. So let us wrap this up. So let me ask Sangeeta to come in for the doing the honors.
Yes, sir. Good evening. On behalf of SkillActz and everyone, I thank our speaker for this wonderful session. I extend my gratitude towards Anand sir for making this event happen, and to Isaac and Jackson for their technical support throughout the session. I am also very grateful to students and all others who are present here today for participating and making this an interactive session. Thank you all. If there are any friends of you who couldn't join, please let them know that the recording of the session will be available on our SkillActz YouTube channel. Thank you all.
Yeah, thank you and all the best.
Thank you, Rajiv. Thank you, everyone.
Yeah, thanks. Bye.
Good night.